You're on.
And then this is going down the negative.
All right.
So let's take a look at this 100.
Yeah.
So the 100 is going in which direction?
Y. I mean Z.
In the Z.
I'm already messing up.
So it's going in the Z, right?
Yeah.
But see that they're diagonal, right? There's a diagonal perpendicular distance between them.
Yeah.
So would you say, looking at it, coming over here, looking at it along the x-axis, does it create a spin about the x-axis?
Yeah. Mm-hmm.
Yeah, it does. It's spinning positive or negative?
Negative.
Negative. And then let's look at the y-axis. Because we know it can't create a moment about the z, right? Because the 100 is in the z.
Right.
Come over here at the y-axis. Does it create a moment about the y-axis too?
Negative.
Yeah, okay, negative.
Yeah.
So we have to do them separate. So let's do the x-axis first. And then the y. So it's 100 times, so we're trying to find the spin about the x-axis. So if the force is in the z, the distance has to be in the what? Everybody look up here. I'm first calculating what the moment is about the x. And if the force is in the z, the distance has to be in the y. So what's the y perpendicular distance between them, Daniel?
Y perpendicular 16.
Right. And it's in the x, right? So we're going to put an I. And is it positive or negative?
Negative.
Negative. Okay, Eugene. Now we're looking at the moment in the y. It's 100, which we know is in the z. So what does the distance have to be in?
The x.
The x. And what is the perpendicular x distance between those?
12.
Right? And does it create a moment about the j? And is it negative or positive?
Move that up and down.
Negative.
Negative. And so what does that value come out to be? Negative 1600 I minus 1200 j. So then what is the answer in the end? What's the sum of all the moments? So let's see. The only one in the I is this one, so it's negative 1600 I minus 1200 j.
2800.
What?
2800.
Okay, let's, well, this is in the K, right? So what's this, 1540? Minus 1540 K. And the units are inch pound. Did I add them up right?
Yeah.
So how did I represent the moment so far?
In vector.
In vector form. How else can I represent it? Magnitude and direction angles. And you already know how to figure that out. But let's, before we go on, let's ask, let me have the question first.
So when you sum up all the moments,
Yes.
is that representing the moment, the total moment due to all the couples?
That's right. So when you sum it up, this whole, what do we want to call it? An S bar, opposite of an S bar. This whole bar here is spinning, right? It's spinning. Because of these couples, it's spinning. And that's a good segue too. Let's draw the 3D spins. Remember, I want you to be comfortable with that. So on the X, it's a negative spin, right? So the fingers aren't going this way, it's going this way. So does that look like what the spin should be?
Yeah.
The moment in the X? And the Y is negative 2. Does that look like it's going into the page, spinning back? And then the Z is also negative. You need to become comfortable drawing these funky little curves. Remember, you gotta leave the little spaces. So Isak, why am I leaving a little space here?
To show that it's going around.
Yeah, to show that the x-axis is in front of that spin, right? Yeah, Santiago.
So the 100 force are diagonal to each other, and you said that we could find the components or find the perpendicular distance.
Well, in this particular, in the case that Eric was asking, it was a different situation. So let's look at this situation first. So in this situation, you know, there's this 100 pound. There's this 100 pound force going up like this, right? And there's a 100 pound force going here. There is a perpendicular distance between them, but it has two components to it, right? It has an a y and an x. So we could leave the force the way it is, because the force is in the z, but we need to break up these two, this perpendicular distance, into the perpendicular distance of the y and the perpendicular distance of the x, in order to find both the x and the y moment. Okay?
So you couldn't do it just finding the perpendicular distance?
No, because if you just multiplied 100 by the perpendicular distance, you would have no direction at all. You have to look at them both isolated. Really good question. Everybody get that?
Yeah.
So here, if I took the 100 pounds and multiplied it by the perpendicular distance, this perpendicular distance has an x and a y component. I would have gotten a number with no direction at all. I had to break up this perpendicular distance into the x and the y component to find it. Okay. The question that Eric had asked is, let's say we have x and y, and we have a force that goes like this and a force that goes like this. Like, let's say it's 100 pounds. You know, if we had this perpendicular distance here of 5 feet, what would I do here? If I wanted to find the moment in this problem, do I have to? The force is in which plane? The xy plane. The distance is in the xy plane. The moment is around, only around the z. I have to break this up into components because there's a moment about the y and the x. But here, as long as they give me the 5, I could just say 100 times 5, 500 foot-pounds. We know it's in the k. K is a positive or a negative? Negative. So I didn't have to break it up. But let's say they didn't give you this distance, and instead they gave you the x distance. I don't even know. What would you do? Okay, let's say they don't give you the 5, but they give you the x and the y. What would you do?
For the components of the force?
I think I would take the components of the force, because this would not be that comfortable for me to find. Well, let's see if this is. Let's just think geometry. This is. I could find x. I could find this guy, right? This isn't good. I would have to find out whatever this k is, right? And then I would have to find this. It's geometry. It might take me too long. So yeah, I would break up the forces into the x and y. And then I would say the fx times the perpendicular distance y, and the fy times the perpendicular distance x. Everybody see this? So in the first problem, they gave you the perpendicular distance, and because everything's in the xy plane, you know the moments in the z, so you didn't have to break it up at all. But if they gave you the x and the y distance, then I would take the forces, and I would take the forces. It's still, a moment is still about the z-axis, but I would break the forces up into components, because that would be quicker for me. But if you are a whiz at geometry, just find that perpendicular distance. Sam?
So then you just add those together?
And then you just add them together, because they're both in the k. Right? Let's look at this. Your x would be going like this, right? And your y would be going like that, am I correct? Am I correct? The x would be going like this and like this, that's positive, that's negative. And then the y, yeah, that's negative too. So you'll come out with the same answer. But if you could find that distance using geometry, you know, it's the height of a triangle, right? When you try to do when you try to do area of a triangle, 1/2 base times height. A is the base and this is the height, you'd have to find out the height. I don't remember. Okay, another problem in 3D. Again, you know, at the end of my class, if anybody wants these, you could have these. The next one is also in the text. Yeah, hold on a second. So we're gonna end, but just so that you know what we're gonna work on. Oops, I'm putting it all in the wrong spots. Hang on. These are all my sheets. If anybody wants them, all right? They're up here. Okay, this is the problem we're gonna do next, which is on page 20. Sarah, did you have one question? Oh, yes. Okay, so let's look at the homework. Let's look at the homework. So on couple, it's going to be due the day after. So what's today? Tuesday? Today's Thursday, right? So back 2 days, that would be 3 plus 7, that's to the 10. And how many of those? There are 5 problems. I mean, you can do it all now. You know, especially the 2D ones, the 2D couples. You might want to do it now while it's fresh in your head rather than waiting a week and a half. You know, things go out of my head pretty quick. You know how to do both. We're going to do, on Tuesday, we will do another, this one. So on Tuesday, our quiz is going to be 3D right-hand rule. Our quiz on Tuesday is going to be 3D right-hand rule. Similar to what we did in class or similar to the workshop. Okay, Daniel?
You know we'll have our exams back? Or
Oh, I think by Tuesday. Should do it this weekend.